Okay, the next part is that we're going to look at where is a function increasing and where is a function decreasing. The way we do that is we always start furthest to the left. So we're going to start right here and we're going to start moving or walking along the x-axis. So we're going to move to the right no matter what. So notice as we move to the right, what's happening to this function as we're moving to the right. So it kind of looks like it's increasing, but it's not. If we're moving to the right, it's actually decreasing as we move to the right, and it keeps decreasing until it hits this point. Once it hits that point, it starts increasing, hits that point, it starts decreasing again. So you'll see over here when we look, kind of slide it over, notice it's decreasing for this first part, increasing for this middle part, and decreasing again for this other part. Notice it starts all the way up here, not on the line. Okay, so it's where it actually turns around and heads in the other direction. So it's either coming down or going up. That's the only two ways that it's doing it. So notice here, coming down, going up, coming down. Okay, and we follow it from the beginning. This is the beginning of the function to the end of the function. So that's how we determine our increasing and decreasing. So when we look at that and we look at the particular function, I'm going to show you how to read it next. So now we have this particular function. You can see as we move this way, the function increases to this point, decreases to this point, and then increases again. So this is asking, where does it decrease? Well, it decreases starting at x equals 0. So when we're looking at where is the function increasing or decreasing, we look at the x values, not the y values. So we are going to see that here x is 0, and then as we walk along the x-axis at 4, which is down here, at 4, the function starts increasing. So the function is decreasing between 0 and 4. So notice here, this is between. So if I write it this way, that means between. So in this particular case, it is between 0 and 4. So that would be B. So if we look at that one, that is B. Okay, so let's move on to the next one. So some more extrema, which we did last time, and we hadn't looked at some of these extremas that we're kind of going through now. Notice here that these are relative minimums, A, C, and E, because they take place in a valley. B, D, and E are at peaks, so they are relative maximums. And then this function, even though it looks like this function is doing this all the time, we can't make the assumption that this is going to turn around. So this looks like it keeps increasing on forever. So that means our absolute maximum would be infinity, and our absolute minimum would be negative infinity, because this one goes down towards negative infinity. Okay, so that's really the difference between those two. Okay, let's see if there's anything else we can get through. Yeah, so we're going to look at it interpreting extrema. And so remember, extrema are all the relative maximum minimums. So here's a relative max, relative min, relative max, relative min, relative max, relative min. And this is a bouncing ball. So what happens, they are defining when it hits the ground, which is our relative minimums. And then at the top, it indicates how high it goes. Of course, if you bounce a ball, the first bounce is going to be high, and then it slowly, what is known as, oscillates down to just staying on the ground. Okay, so it's just really just asking you those different ones. So, okay. Okay, so that would be your check. Now we're going to move on to end behaviors, which should be the last part. We might have one more, but we're really close at this point.